Hi everyone, my name is Asdeep and currently I am pursuing my masters from IIT Jammu in chemistry, and my topic of discussion is CFT, which is crystal field theory. So this theory is generally discuss about the behavior of transition metal ion in a coordination complexes, and various geometries formed by coordination complexes like tetrahedral, octahedral, square planar, TBP, and there are many more. So why do we need this theory? So the need of this theory is because we already have so many theories like VBT, Werner theory before this theory. So why we need this theory is because it's explained better way than the VBT about the color of a coordination complexes, magnetic properties, and reactivity of a complexes in a more accurate way than the VBT. So the according to this theory, because this theory is given by physicist, so according to him, the interaction between a metal and a ligand is purely ionic, purely electrostatic. So electrostatic interaction means that the metal having a nucleus containing a positive charge, it will attract the electrons of a ligand, and due to this interaction ligand came closer to the metal, and when it came closer to the metal, the electrons of a metal d orbitals and the ligand electrons are repel each other due to both having a negative charge, and due to this repulsion the orbitals get splitted into a different sets that I am going to discuss today mainly. So what basically happening is, before directly talking about that this physicist give a to discuss about the two kind of interaction. First one is primary interaction, and secondary interaction. This primary interaction is metal ligand interaction, and this secondary interaction is ligand and metal d orbitals, the electrons interaction, which is generally, which you can say it's a repulsive repulsive interaction, due to which orbitals get splitted. So let's get more deeper into that. So let's consider that initially our metal d orbitals, these are five, these are d orbitals, which is dxy, dyz, dzx, dx square minus y square, and dz square. These are metal d orbitals, and initially they all are in ground state. So when the ligand is at the infinite distance from the metal ion, so there is no any kind of such interaction that will affect these orbitals of a metal. But when ligand came close to the metal, then what will happening is all these orbitals are getting excited, and it will form like at a certain higher energy level than as compared to the ground state energy level. So it will form like this. So they get slightly excited from its ground state, and due to secondary interaction, what will happen, these orbitals get splitted into different sets, and how they get splitted, it depends on that how ligand approaches towards the metal, in which direction ligand approaches towards the metal. If a ligand, suppose ligand approaches along the axis, then the orbitals which lies along the axis, they get more destabilized and having a higher energy as compared to the orbitals which are not in a direct contact with the ligand. So to get more deeper into it, let's move forward. So let me erase it. So now let's discuss by considering an example of octahedral geometry. So let us consider this as our z-axis, x-axis and y-axis. So let us suppose this is our cube and the metal ion is present in between the center of this cube. So ligands are approaches. This is our axis. So ligands are approached. In case of octahedral geometry, we know that ligands are approaches in along the axis. So this is our first ligand, second ligand, third ligand, fourth ligand. So all these ligands are approaches toward the metal along the axis. So due to which what will happen, the orbitals which are along the axis, they get more destabilized as compared to the orbitals which are lying in between the axis. They get less destabilized, and the more destabilized set of orbitals are called unstable orbitals, and the less destabilized set of orbitals we call it as a stable set of orbitals. So due to which what happened, this initially all the orbitals get destabilized, and because of this secondary interaction, splitting of the orbitals take place, and the orbitals which lying along the axis, which is Eg set of orbitals, are getting more destabilized, and the orbitals which are in between the axis, which is T2G set of orbitals, are getting kind of stabilized set of orbitals. We consider it as a stabilized set of orbitals. So these are dx square minus y square and dz square, and this is our dxy, dyz and dzx. We call it as a G, which G represent that this our octahedral geometry is symmetrical. Means if we move along this direction, then we get a ligand. Then we get a same ligand if we move along the opposite direction also. So this is our G rate, and this T2 means triply degenerate, and E means doubly degenerate, means 2 orbitals having the same energy and 3 orbitals having the same energy. Doubly degenerate set of orbitals, and this center of these orbitals are barycenter, and this splitting is known as delta O in case of octahedral geometry, and we call it as a CFSC, crystal field splitting energy. So this is the whole concept of crystal field theory and basic idea about the crystal field theory. Hope you like it. Thank you.